Welcome to homework help for Newton's second law and friction problem set number 2, aka Ernesto's worksheet. At this point, we have all of our formulas. So we have the formula for weight, we have Newton's second law, we know that free body diagrams are vector diagrams, so that's the sum of forces formula, and we also know that we can calculate friction. Okay, so when we look at these, if the free body diagram is not already drawn, you need to draw it in first. For most of these, it's already drawn in for you. Okay, so if we take a look at number 1, we have a rightward force applied to a 6-kilogram object to move it across a rough surface at constant velocity. So right off the bat, we have really important words. What does constant velocity mean? Think about that while we read the rest of the problem. Okay, our object encounters 15 newtons of frictional force. We will use the diagram to determine gravitational force, normal force, net force, and applied force. And we are neglecting any kind of air resistance. Okay, so they have gone ahead and given us a nice little box that tells us the mass, and they tell us the acceleration is 0, and the reason that we can say it's 0 is because it said that the object was moving at constant velocity. So that means net force is 0. And if net force is 0, that also means that all the forces have to balance each other. Okay? So, if I have 15 newtons of friction to the left, then I must also have 15 newtons of applied force to the right. Right? Those have to balance. If I then know my mass, I can find the weight. Okay, so Fg equals mg. So I'm going to do 6 kilograms times 9.8 meters per second squared. And I get an Fg of 58.8 newtons. Okay, so I can fill that in for Fg. And then again, I know that net force is 0. All my forces have to balance. So that means my normal force also has to be 58.8 newtons. Okay, so let's go back and make sure we answered everything. We did force of gravity, we did normal force, we did net force, and we did applied force. So we have finished this problem. Number 2, just a hint, also says it's at constant velocity. So think about what that means for net force when you start solving. Okay. I'm going to skip to number 3. Number 3 has a rightward acceleration, so we know that net force will not be 0. Okay. They've told us that acceleration is 2 meters per second squared, right, or positive. They told us that the coefficient of friction is 0.1. They've given us a mass of 5. And then we want to determine gravity, normal, applied, friction, and net force. Okay, so looking at our picture, there are several things that we could do first. Let's just pick gravity first. Okay, so Fg equals mg. So mass was 5 kilograms. G is 9.8. And so 5 times 9.8 gives us an Fg of 49 newtons. I happen to know that the box is not falling through the floor. It's not rising up. I can assume that based on the picture they gave us. So that means normal force will also be 49 newtons. Okay. Now that I know my normal force, and they gave me the coefficient of friction, I can actually solve for the force of friction. Right? So the coefficient was given as 0.1. And the normal force I just calculated was 49. And so my force of friction will be 4.9 newtons. Okay. I don't know my applied force, but what I could do is solve for my net force using Newton's second law, F net equals ma. So I have 5 kilograms of mass, of a positive 2 meters per second squared for acceleration. So my net force will be positive 10 newtons. Okay. And then with that information, I can use my F net equals sum of all the forces formula to figure out the applied force. So I'm going to write my own formula based on the picture. I'm going to say that net force must equal FA minus FF. I do it in that order specifically because I put friction, or they showed friction on the left would be a negative force, applied is on the right, which would be a positive force. And then I don't include normal or gravity because those balance out. Okay, so I don't know my applied force, but I do know that net force was 10 newtons. And then I know that friction was 4.9 newtons. So to solve, I'm going to add 4.9 to both sides. And I get an applied force of positive 14.9 newtons. And I go back and make sure that I answered everything. And I see that I have FG, FN, FA, FF, and net force, so I have answered them all. Okay, so these problems work in this pattern. You're going to start with the picture, and then you're going to just sort of work your way around them, solving for whatever you can solve. There's not a specific order you have to go in, but each force that you can find just gives you another piece of the puzzle. As always, if you need more help, please reach out.